Okay, so this short lesson will be regarding isolating the variables, pretty much solving. So the first example that I will do with you is a very simple one, is a linear equation. So we'll have 2x plus 5 is equal to 21. How are we solving this, and how are we finding the x, or which in other words is isolating the variable? So the logic that stands behind it is that what we are trying to make the variable to stay on its own. So we will start with subtracting first here, and what we are doing in one side is we are doing on the other side, because why subtracting? To cancel the plus 5 that we have. So plus 5 is cancelled, and then on the left side of the equation is 2x, and on the right side is 21 minus 5, which is 16. And then in order to isolate the x here further, we have to divide both sides by 2. Why divide? Because between 2 and x there is a multiplying, and in order to cancel the multiplying we have to divide it, so then x is equal to 8. This is the first example. And then the second example is another one, very simple one, which will be, let's say 3x minus 12 is equal to 33. Then again we are trying to isolate for x here, or to solve for x, and in order to do so, first we'll start with adding and subtracting, canceling it out, and in this case is subtracting. In order to subtract the to cancel the subtracting, we will add 12 in both sides, so the 12 is cancelled, and then 3x will be equals to 45. And then again, since we are multiplying x by 3, we will divide, because the opposite operation of multiplying is dividing, so x will be equals to 15. The third example is a bit more complicated. We are dealing with fractions here. So let's suppose that we have 1x is equal to 1 over 3 plus 2 over 4. Okay, yeah, 2 over 4. Now the lowest common denominator that we are doing here, we are solving here, is 12x. So what do? Is we write those three fractions that we have with the denominator 12x. So then the logic that we are using is, or the question that we are asking ourselves here is, what am I multiplying x by to give me 12x? And this will be, we are multiplying it by 12. What are you multiplying 3 by to give you 12x? Is 4x. What are you multiplying 4 by to give you 12x? So this will be, you are multiplying it by 3, but you have a 2 here, so 2 times 3x. And then after that, with the condition that x cannot be equal to 0, you can cancel out the denominator, and you are left with the numerator, that is 12x is equal to 4x plus 6x, or 10x is equal, because you add the like terms here, is equal to 12, which after dividing both sides by 10, then x will be equals to 12 over 10, or in lowest terms, 6 over 5, or 1.2 as a fraction. Now, when we are dealing with isolating the variables, we are Another example that we have to consider is when we have a bunch of variables like acceleration is equal to v final minus v initial over time. And now what we are doing is we are solving for, let's suppose, t. In this case, what we will do is I will use a different color so that you can see that in this case, what we are using is we are multiplying both sides by t, and then we will have at is equal to v final minus v initial, and dividing both sides by a, so canceling it out, so t will be equal to v final minus v initial over a. So in this case, what we are doing is we are dealing with literal equations, which will be a different lesson, short lesson as well. Okay.